Hello, my name is Sophia. I am a third-year computer engineering student and the current president of the Wireless Communication Enterprise. This is now my second year with WCE in the Enterprise program, which has been a fundamental part of my education here at Michigan Tech. We are an electrical and computer engineering enterprise. We focus on wireless communications, photonics, embedded systems, biomedical application, and power. We're actually one of the original 3 enterprises founded in 1999 by our current advisor, Cischke. We now have 25 members and 6 teams. Before we get into our teams, though, I would like to take a second to thank our sponsors. Stellantis, Pfizer, and Bobo and Snowmobile Club. We would not be able to do what we do without your support, so thank you. We do appreciate you. We have 6 project teams in WCE this year, some of which are externally sponsored, while others were brought to the enterprise by students who just wanted to work on them. Each of these teams have 3 to 5 members, and they're all working on really cool projects. We only have time to highlight 2 of them today, though, as shown in red. So, first team that we're highlighting today is the Snowmobile Pre-Collision Alert System, with support from Bobo and Snowmobile Club. General idea of this one is they are working on designing a device that can detect oncoming snowmobiles and alert the drivers before they end up in a collision. Ideally, this should be less expensive than existing solutions to this problem and should be able to detect oncoming snowmobiles regardless of what is on that other snowmobile. Key skills and topics for this one include machine learning, infrared and thermal imaging, image processing, and utilizing a Raspberry Pi, which ties into some of our main disciplines such as wireless communications and embedded systems. One of the main problems faced by this project was getting the machine learning algorithm to actually recognize when there is a hotspot within the image in order to detect it as a snowmobile and properly alert the driver. Originally, the snowmobiles blended into the environment a little too much in infrared, and the machine learning model was not able to detect them accurately enough. So in order to fix this, they actually developed a custom image filtering system and restructured the model to operate in grayscale, as you can see in the images up to the side. They managed to up the contrast by a lot in order to make the snowmobiles more obvious and make it easier for the machine learning algorithm to detect and let the driver know that there was a snowmobile there. So just to demonstrate how this technology works, we actually have a video. I will let Zach take it away from here.
All right, so I'm Zach here with WC. I'm working on the Snowmobile Anti-Collision project. Right here we have an infrared camera that is reading images into our Raspberry Pi. We are then filtering those images using a saturation filter to pick up on hotspots, as you can see here. Using those hotspots, we're running those images through a machine learning model, trying to pick up on the shape of those hotspots, and using those we can create early alerts to prevent collisions on snowmobiles and other all-terrain vehicles against like deer and other wildlife, against other snowmobilers, against people on the trails, and anything of that sort.
Our other highlighted project today is the user-friendly LED, or as we like to refer to it, UFLED. This one's actually internally sponsored. It was brought to us by students. They're working on designing a simple, user-friendly GUI application with features that make it as easy as possible to make patterns on LED matrices. And is intended to generate code that programs these chain-together LED matrices to display the patterns design in the GUI application. So some of the key skills and topics in this one include using GUI building libraries and applications, programming microcontrollers, and communicating in between devices, which ties into one of our main disciplines of embedded systems. Now, one of the problems that this team faced was debugging their printed circuit board, which was intended to expand the number of attachable matrices. They found the issue by probing it with an oscilloscope, and they'd actually discovered that there was a bad driver. So they did manage to fix it by desoldering and clipping the legs on said driver before resoldering. They do now have a functional system, which is demonstrated here by Luke.
Name the file video. Make a image without coding a single line of code. Can you believe it? An image with not a line of code coded. Anyone can do this. Anyone. And then you're just like, let me preview this little guy. Oh, okay. So then it's like I'm gonna print the whole data, all that data out. All it is copy and paste. That's all she is. All she wrote. We're gonna launch. Boom. Look at that. Smiley face and all.
So to wrap up, we are the Wireless Communication Enterprise, part of the Electrical and Computer Engineering Department at Michigan Tech. We specialize in wireless communications, photonics, embedded systems, biomedical application, and power. I would also like to thank here all of the folks who helped me make this video, including Brendan, Zach, Luke, and Kit. Thank you for helping, and thank you all for watching.